We are going to go over the falling objects worksheet right now, and this will be just on part 1 on the first page, and then I'll have another one for part 2. All right, first way to go over the problem is to make sure you hear what the directions were before, and I want you to skip this entire section. It's too basic. It's just V D over T. We're past that, so I don't want you to do it. Okay, now you're going to get a meter stick or a ruler, and I want you to measure these distances. Okay, first it just asks a basic question, and this is for Physics 1 students, and so hopefully you understand that if you have trouble with this worksheet, you are overthinking it. This is a much more basic worksheet. It's more about the concepts. So if you're getting frustrated, you're overthinking it. Okay, first it's going to ask, why is the spacing of the BB farther apart? And as it falls. So you should understand, why would it, if the distance here is 1, the next second it goes farther, the next second it goes farther, and hopefully you can say, well, it's speeding up. So that's why the distances are getting farther apart. Okay, now you're going to use a meter stick, and you're going to measure these distances. So you have first the distances total. So after 1 second, you have a measurement of 1. Okay? After 2 seconds, I'll put that down. After 2 seconds, you have a measurement of 4 centimeters. You should be using a centimeters, using a meter stick. Make sure you have it in centimeters. This is in centimeters. All right. After 3 seconds, I'm sorry, after 2, we need to put it in. So after 2 seconds, it fell 4 centimeters. All right. After 3 seconds, that total distance will be 9. And they even did 4 seconds for you, but after 4 seconds, if you measure it, you should see 16. So the total distances, this graph or this table here is total distances. It's just going to be 1, 4, 9, 16. Now, looking at those distances, it's asked this question: do you see a square relation between time and distance? 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. So hopefully you can answer that question right now. All right. Now, next table is talking about the distances in between. And for your distances in between, again, we talked about this in the lecture, but your distances in between from here to here is still going to be 1. All right, so that's still 1. What's the distance from this point to that point going to be? Well, you can measure it with a ruler again, or you can remember that if this total distance was 4, then this distance should be 3. 4 minus 1 should be 3. And that's going to get ugly. There we go. All right, this next distance. All right, from here to here. Well, if you measure that off, you should get a distance of 5. All right, and the last distance from the bottom to the next time up there should be 7. So the big concept here was understanding distances in between time intervals. So from 0 to 1 seconds, let me use another marker, from 0 to 1, that was 1. From 1 to 2 is the next time interval. From 2 to 3, and from 3 to 4. All right, and looking at those numbers, hopefully you see 1, 3, 5, 7 are odd numbers. So when you see the question, do you see an odd integer pattern? You answer yes. And it says predict the next 3 falling distances, so hopefully you can predict the next 3 odd numbers. All right, now here, this statement down here is very important, and this was in your notes. You might even have a gateway quiz on it, but it says for an object falling from rest, and here's a statement: total distance matches the square of the time, and distance is falling between or during successive time units. So basically between each time unit, match a sequence of blank numbers. What type of numbers are those? Okay, that's how to do the page 1 of falling objects.